Integration by parts. The first thing which comes to our mind after hearing integration by parts is, what is this thing? Basically, it is derived from our good old friend product rule, which we used in differentiation. The rule states any function which are being multiplied together, their derivative is this, where u and v are functions. For example, if we try to differentiate x times cos x, we can say that x is u and cos x is v. When we differentiate it, we will write this by using the product rule as u prime times v plus u times v prime, which is the differential of x, which is 1, times v, which is cos x, plus u, which is our x, times the differential of cos x, which is minus sin x. This makes cos x minus x sin x, the differential of x cos x. If we try to integrate our product rule, we get something like this. Which we can put like this. This is the general form of integration by parts. We can also rewrite this as integral of u times dv is equals to uv minus integral of v times du. Okay, so let's understand this with an example. Consider we have to find the integral of x times e to the power x with respect to x. Now we have to decide which function will become our u and which will become dv, because according to the formula we need our integral should be in this form. So there's a trick in order to find u, which is known as LIATE. LIATE stands for the priority. LIATE is basically the priority which we set to decide which should be our u. In this trick, I stands for inverse function. Like the first, if in our function there is an inverse function like tan inverse, sine inverse, or anything like this, we will assign u to it. If there is no inverse, then we will consider logs such as ln and such. If not, then any algebraic function. If not, then any trigonometric. If not, then exponential. This means because u is a term which we will be differentiating in our next steps, we separate the harder part of the function to differentiate, so that we get the easier part to integrate, which is dv. In this example, are easier using the LIATE trick. Since we do not have any inverse or log function in this integration question, the most prioritized thing is a, which is algebraic. A u will be x and dv will be ex, the remaining part. Now, in order to further solve this integration by part, we need du and v. Du is basically a differential of u, which is here 1, since differential of x is 1. Now we knew this, that integration, in order to integrate ax, if we try to integrate e to the power x, we get e to the power x. So now when we further break down this integral, we get uv, which is x times ex is the e to the power x, minus v, which is e to the power x times du, which is 1. So we can rewrite this as x times e to the power x minus integral of e to the power x. Now we know if we integrate e to the power x, we get the same function. So our final answer will be x times e to the power x minus e to the power x plus c. The plus c is a constant. Let's try a harder problem. What if we had x times sin x, integrating with respect to x. Now using the LIATE trick, we will again set u as x, meaning dv is sin x. The differential of x is 1, and we know that if we integrate sin x, we get minus cos x. So u times v, which is minus x times cos x minus the integral of sin x. The integral of sin x is minus cos x. So our final answer will be minus cos x times cos x plus c. What if we had to integrate ln x? Here we do not have any second function, but we can manipulate the function such that if we multiply this by 1, we get same ln x. So we can rewrite this as integral of 1 times ln x. Using our LIATE trick, we will set u to a log function, which is ln x, and dv becomes 1. Since we are integrating with respect to x, we can write v as x. When we integrate dv, we get x. The differential of ln x is 1 upon x. Rewriting this, we get u times v, which is ln x times x minus one upon x times x. Both x cancel out and we get 1x to the x times ln x minus integral of 1, which is here. Since we are integrating with respect to x, we get x times ln x minus x plus c. Let's try an even harder problem. X squared times a to the power x dx. Now here, using our LIATE, we set u to x squared and dv is e to the power x. dv is 2x and v is e to the power x. Now integrating this function, we get first part is uv, which is here x squared times e to the power x minus the integral of v, which is e to the power x times 2x. Now note here, we have to use integration by parts again, since these two are product. These two are two functions multiplying with each other. So we have to perform another integration by parts. Here we will set u as 2x and dv as e to the power x. Our du is 2 and our v is e to the power x. Now we can rewrite this as x squared times e to the power x minus 2 times e to the power x minus the integral of du times v, which is 2e to the power x. We can rewrite this as x squared times e to the power x minus 2x times e to the power x minus plus, since the sign changed, 2 to the power 2 times e to the power x plus c. Now let's try to integrate tan inverse of x with respect to x. Okay, so now here we have the same kind of question which we had earlier with the integral of ln x. Here we can multiply tan inverse of x with 1. Using our property of LIATE, we will set the inverse, the tan inverse as our u. So u is equals to tan inverse of x. Du will become 1 upon 1 plus x squared. Our dv is 1 and our v will become x. So we can rewrite this as u times c, which is x times tan inverse of x minus the integral of du times v, which is x upon 1 plus x squared dx. Okay, so we know if you try to integrate this thing, which is integral of x upon 1 plus x squared, we note that the upper part is the differential of the lower part such that if we multiply it by half. What do I mean by this is, if we differentiate 1 plus x squared, we get 2x, and if we divide it by 2, we get x, which is the numerator of this fraction. So we can rewrite this using the properties we learned in integration as 1 upon 2 ln of 1 plus x squared. So our final answer will be x times tan inverse of x minus half ln of 1 plus x squared plus c.